Okay, good afternoon, everyone. I know it's, as Rachel said earlier, it's been a very long day, and I know that an interesting presentation by now means a short presentation, so I'll try to be quick. I was introduced earlier by Jerry. My name is Dalia El Banna, and I'm a new PhD student at the Faculty of T, School of Digital Media Technology. My presentation today will be very closely related to Jerry's presentation earlier this session. It will be about the Flexilink protocol. It's the new technology that we've been researching in the DMT lab at the Faculty of T. I will start from a slightly different perspective than Jerry. As you are all aware that the internet has been a key aspect of our daily life. I mean, it's very hard to imagine the industry, our work life, even our social life without the absence of the internet. However, with 50 billion devices that are expected to be connected to the network, to the internet by 2020, this only implies that we will have an explosion of traffic and data that can reach up to 1,000 times greater than the current traffic the internet is dealing with. This in turn means that more and more power consumption in terms of the devices, of the network devices that are responsible for keeping the traffic going through the internet. And there has been concerns in the past few years that our tendency to conserve energy will hinder the performance and the development of the internet to sustain all this expected traffic. So worldwide research organization and the standardization organizations worldwide, like the ISO, for example, the International Telecommunication Union, have been working on keying the term that we now know as the future networks or the next generation networks. They have been addressing the issues that they think that the current internet infrastructure is failing to comply with, and the services that they think that it will not be able, that the current infrastructure of the internet will not be able to provide in the near future. One of these services, as was mentioned earlier in Jerry's presentation, is the live streaming of audio and video data over the internet, and I'm sure you can all relate to the buffer icon that keeps going, flashing round and round when you are trying to stream live video through the internet. Why does the infrastructure, the current infrastructure of the internet, fails to comply with this kind of service, like live audio and video streaming? Simply because its main design was only to keep the traffic going from the source to destination without any thinking of when this information will reach the destination. Again, as Jerry mentioned in his presentation, you can just send an email and you don't care if it will go there half a second later or 2 seconds later or maybe a minute later. You just don't care, it just reached the destination. So the approach to solve these shortcomings of the current infrastructure of the internet have been done through two approaches. The main approach that we deal with every day now is utilizing the higher layer protocols like real-time protocols and the diff-serve protocols to try to prioritize basically the data in terms to identify the data that are time critical and time sensitive, send it first, and then the other best effort data that they are not that time critical. The main problem with this approach is that introduce a huge amount of headings or headers, sorry, a huge amount of extra data to the traffic, and this again implies that it's more power consumption in terms of the devices having to check single packet by packet to deliver it to the destination. The other approach, which fits extremely well with the concept of the future networks or the next generation networks, is to completely redesign the layer 2 protocols in order to introduce timing characteristics to the network, and this is where our research in the digital media lab is based through. There has been a couple of calibrations in this term by introducing the time-triggered Ethernet protocol and the audio-video bridging protocol, and in our case by introducing the Flexilink as well. So I'm sure you can relate to the same diagram used by Jerry earlier. So we again, with the industry, with the 9 Tiles company, they introduced back in 2010 the new protocol, which is called Flexilink. It offers a unified infrastructure for the network to be able to support not only the time-deterministic or time-sensitive data, but also the best effort data that we deal with on our daily dealing with the computer networks or the internet. Why Flexilink? Flexilink, we can see it as a very competitive and a very promising new technology. It combines both the advantages of the time division multiplexing model and the best effort model for data. It has a guaranteed bandwidth. The delay, which is key point to the streaming of the live media, fails between the 5 to 10 microsecond per hop, and this is only using the 1 gigabit per second internet. Again, a very key feature of the Flexilink is that it achieves a full utilization of the bandwidth as opposed to other peer protocols, which I mentioned earlier, like the time-triggered Ethernet or the audio-video bridging protocol. Flexilink, or this type of time characteristic layer 2 protocols, will not only benefit the live streaming of media over the internet or the broadcasting media, but also can benefit other networks that deal with time-sensitive data, like, for example, the in-car networks or the avionics industry. Both of these examples do have sensitive data that needs to be delivered to its destination on a timely manner. So the development of the Flexilink, I will sort of take you through the roadmap of the development of the Flexilink protocol. As I mentioned earlier, it was introduced in 2010, and it was first introduced by 9 Tiles, so it's an initiative from the industry. They have developed, with the protocol, they do have developed a prototype network architecture and interface cards that they will use as a testing for the performance of the protocol. Our role here, or our contribution to the development of the protocol in the DMT lab and in BCU, will be, first of all, to develop a simulation model that will help to test the performance of the protocol, of course changing many aspects about the network or about the protocol, and see the effect of this on the performance of the Flexilink. We will be setting also a network test bed for, again, testing the performance of the Flexilink through connecting multiple Flexilink nodes together with normal Ethernet nodes, perhaps, and see how the Flexilink will perform in the presence of traffic. And being a new initiative, a newly introduced technology, it does have lots of open research questions that we will be looking at in our team, with our research team in DMT. Like, for example, having the Flexilink, how it will work in terms of the WAN networks not only being confined to the LAN, how it will work over other physical layer, not just the Ethernet, the 1 gigabit Ethernet, how it will perform over the wireless, for example, physical layer. I will try to be as quick as possible with the technical details, but again, this is sort of how the frame, the actual frame will look like with all the SF data. The SF data are the time-sensitive data, and the AF data stands for the best effort data. This is a very initial work in terms of developing the simulation model. We are testing it over 2 host network. These network nodes are completely redesigned. They are not the yes, I know. They are not the traditional Ethernet network. They are completely redesigned. And I know that my time is up, so I don't want to exceed my limit. So, to sum up, as a conclusion, we do believe that the Flexilink protocol is a very promising technology that we are working closely with the industry to develop, and we're hoping to solve many of the open research questions that we have now, that I've mentioned earlier. Thank you.